a differential equation in which 3 roots were coincident, say, let's say I had like a d minus alpha whole cubed, d minus alpha whole cubed into some phi d acting on, suppose this was the differential equation. There were 3 coincident roots, and this would have other, phi d would have other factors, let's say d minus alpha 1, d minus alpha 2, etc. Then if 3 roots were coincident, then the contribution made by this factor, the contribution made by this factor to the general solution would be just the contribution of this to the general solution, right, would be C1 plus C2x plus C3x squared e power alpha x. If 3 roots were coincident, then the contribution made by those 3 put together would be C1 plus C2x plus C3x squared e power alpha x. This was the operator. This entire thing was FD, which is like d minus alpha whole cubed into some other operator acting on y equal to 0, right? The contribution made by the 3 repeated roots of FD, that is of Fm, alpha alpha alpha, to the general solution would be this. Other factors would contribute the way they were, arbitrary constant, e power alpha, arbitrary constant, but these 3 factors, alpha alpha alpha, would give this to the general solution, and we'll have arbitrary constants as desired. All right. So if we had, let's say, a differential equation of the following kind, d minus 3 whole cubed d plus 1 d minus 2 acting on y equal to 0, what would be the solution to the differential equation? The contribution made by these 3 factors would be C1 plus C2x plus C3x squared e power 3x plus some C4 e power minus x plus C5 e power 2x. That's the general solution to this. In the event 3 of the real roots were coincident, right? A generalization is, suppose we had alpha, a root which was repeated r times, this is repeated 3 times, earlier 2 times, and then repeated r times, and and set of other factors, d minus alpha 2, alpha 3, etc., acting on y equal to 0. If this was the differential equation, then let me say again without proof, the contribution made by r values of alpha here, r of these factors will make a contribution to the general solution of the following kind. The contribution made to the general solution C1 plus C2x plus C3x squared plus CR x power r minus 1 e power alpha x is the contribution that this factor would make to the general solution. Other factors would contribute, like I discussed, but these are coincident roots, alpha 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 r times would contribute this to the general scheme of the solution. Got me? Can I wipe this off? So now if I said d minus 1 whole to power 4 d plus 1 d minus 2 acting on y equal to 0, if I had to write the general solution to this differential equation, it's going to be C1 plus C2x plus C3x squared plus C4x cubed e power x plus C5 e power minus x plus C6 e power 2x. This would be the general solution to the differential equation. So do you realize how the repeated roots contribute to the general solution? Clear? Now You're all comfortable so far, I presume, right? You understand all that I'm saying. Now suppose in addition to real roots, it had complex roots. And if these coefficients a0, a1, a2, an were real, then complex roots will always occur in pairs. Which means, suppose alpha plus I beta was one of the complex roots, then alpha minus I beta would also be a complex root. Would also be a root of fd equal to 0, right? fm equal to 0, fm equal to 0, sorry. So we had, let's say, d minus alpha plus I beta, d minus alpha minus I beta into some phi d equal to 0. So the two complex roots which occurred in pair, like alpha plus I beta and alpha minus I beta, right? The others were all real roots. They could be coincident or real. They could be, coincident or distinct. And you know what to do with the coincident roots, what to do with the distinct roots. The contribution made by the various factors of some phi d acting on y equal to 0. Now the contribution, this is like m1, this is like m2. Let me just look at the contribution made by the two complex roots. The contribution made by the two complex roots to the general solution would be c1 e power m1x, they are distinct after all, they are distinct, plus c2 e power m2x would be the contribution made by the two complex roots, alpha plus I beta and alpha minus I beta. So this is not the complete solution, this is just the contribution made by the two complex roots, right? So then this would be like c1 e power alpha plus I beta x plus c2 e power alpha minus I beta x. Now this is e power, this is like c1 e power I beta x plus c2 e power minus I beta x e power alpha x, right? Hey, but e power I beta x is cos beta x plus I sin beta x, e power minus I beta x would be cos beta x minus I sin beta x, right? E power alpha x, yes or no? Now this I can write as cos beta x into c1 plus c2 plus sin beta x, I sin beta x into I c1 minus I c2, right? This I can write as c1 plus c2 cos beta x plus I into c1 minus c2 sin beta x into e power beta x. I'm sorry, e power alpha x, e power alpha x. Hey, but c1 plus c2 is one constant c1 prime and I into c1 minus c2 is another constant, call it c2 prime. So this can be written as c1 prime cos beta x plus c2 prime sin beta x into what I am calling I into c1 minus c2 as c2 prime. I am calling I into c1 minus c2 as c2 prime, right? That's also constant. I mean, if this is a constant, this into I would also be a constant. Into e power alpha x That's the contribution made. So if alpha plus I beta and alpha minus I beta were a pair of complex roots of Fm equal to 0, then the contribution made by that pair, consolidated contribution made by that pair, would be e power, this is alpha, the real part into x, into arbitrary constant into cos imaginary part into x plus C2 sine imaginary part into x. That's the contribution made. Is that all right? And other factors would contribute as discussed. Say for example, don't get fidgety. Suppose I have d squared plus d plus 1 acting on y. D squared plus d plus 1 acting on y equal to 0. That is fd acting on y equal to 0. Alright. Now, what is Fm equal to 0? Fm equal to 0 would be like a m squared plus m plus 1 equal to 0. Then the two values of m would be complex here because the discriminant is less than 0. Minus 1 plus minus root 3i divided by 2 minus b plus minus root b squared minus 4ac by 2a, right, which is like a minus half plus minus root 3 by 2i, minus half plus minus root 3 by 2i. So then the two complex roots are, see, alpha is minus half here and beta is root 3 by 2, right? Then the solution to this differential equation would be, so the roots are like a alpha plus minus I beta are the two roots. So then the general solution to this differential equation would be y equal to c1 e power alpha x, that is minus x by 2 into c1 cos beta x cos root 3 by 2 x plus c2 sin beta x. That would be the general solution. E power alpha x c1 cos beta x plus c2 sin beta x. That's the contribution made by the pair of complex roots that occurred in pairs. Now, what if these complex roots were repeated? I mean, they could be repeated. For example, you know, if I said this squared equal to 0, then alpha plus I beta is occurring twice, alpha minus I beta is occurring twice. Alpha plus I beta is occurring twice and alpha minus I beta is also occurring twice. Then I'll tell you, there is nothing to worry. All that you need to do is, suppose in this case they are repeated twice, right? If they are repeated twice, all that you need to do is right or equal e power minus x by 2 c1 plus c1 prime x cos root 3 by 2x c2 plus c2 prime x sin root 3 by 2x. So this is in the event of, let's say, alpha plus I beta and alpha minus I beta appearing twice. In this case they appear twice. If they appear thrice, if I said this cube, then c1 plus c1 prime x plus c1 double prime x squared, and same thing here. If they appear r times, same scheme of things. So you know what to do in the event complex roots are also repeated. Complex roots are repeated. Obviously their pairs would also be repeated, and then all pairs put together would give you this as their contribution, right? I feel extremely incomplete to stop differential equations at this point, because this is not even a drop in the ocean. But then it's all right to stop here, given the plight that you have suffered. I can, hey, one thing. अरे देखने तो दे यार. Now, what I want to do is, first of all, today was Eid, and I know tomorrow is school. But what I want to do is, tomorrow morning, 10 o'clock. कौन सा एग्जाम है? Tomorrow